What we'll cover today is we'll cover the cross method. And what this is it's one way that will help us factorize quadratic equations. And I'm aware that it's not taught at some schools. So I just want to cover it with you guys today. So what we'll start off with is we'll start with monic quadratics or monic quadratic equations, which means that when you do have an equation, let's say x squared plus 4x plus 4, there will be no coefficient before the x squared. So there won't be a 4, there won't be a 5, there's nothing. So solving this, there might be different ways of doing this, but I'll just show you guys how it's done with the cross method. So how this essentially works is we want to find the products, well, two things that multiply together to give us the x squared, right? And thinking about two things that multiply together to give x squared, it's pretty much just x and also x down here. We can then draw the cross to go crossover, and this will be explained in a second. What we want to find next is we want to find the factors of 4, right? So some factors of 4 include 1 and 4, and also we have 2 and 2, right? So these are the numbers we're testing out. So what we want to find with the numbers on the right side of the cross is we want to find the products that work together to give us 4 when they're multiplied together, right? So 1 and 4, 1 times 4 is 4, 2 and 4, 2 times 2 is 4, right? But before we plug anything, we want to test whether if we multiply and add across the diagonals, like this and this, whether they'd equal 4x, right? So we can try it. Let's say, for example, we used 1 and 4, right? So what we'll do is we'll follow the diagonal. We'll start from the top. So from here, all the way to here, we have 4 times x, which is 4x, and we add that with the other diagonal, which is 1 times x, which is just x, which gives us 5x, right? So all in all, x times x gives us x squared. The cross multiplication gives us 5x, which doesn't match up just right. And 1 times 4 gives us 4, which works. So we know that this won't work because the middle doesn't match up. So what we'll do is we'll try it again. And it takes a bit of practice before you get it, but it's a very efficient method. So let's try x and x. And this time, instead of 1 and 4, let's try 2 and 2, right? So we know that 2 times 2 is 4, x times x is x squared. And now we just want to find out if it satisfies the middle. So x times 2, we get 2x plus, and 2 times x again, we get 2x, which is 4x. And these two now match up just perfectly. Now, we found our solution using the cross method, but now we want to know how we write it out. So a conventional mistake that a lot of people make is they write it out in terms of the cross like that. So they might write it as, x plus 2 and x plus 2. Now, while this is the correct answer to this case, it won't always apply in every case, especially when you go to non-monic questions where you might have a 3 at the front or a 4, 5, 6, etc. So what we want to do instead of that is, with the two numbers, we always want to write across, right? So when we multiply to find the middle, we go across the diagonals. But when we want to write it out in factorized form, we want to write it out like this first. So x plus 2. And then we want to write this second, which is also x plus 2, right? So that's x squared plus 4x plus 4 factorized. Now, while this might work for something like, this question, we can go through another one to see how else it works. Okay. So let's say we are given x squared plus 3x minus 10. What would we do in this case? So to start off the cross method it's pretty much the same in all conditions. So you always start off with the multiplication. What two things multiply to give us x squared? In this case, it's just x and x. Then we draw the diagonal lines across. And now we think about the products, two numbers that multiply together to give us negative 10. So because we have a negative, we have to be aware of what's going on. So we can't have two positive numbers, right? We can't have 2 and 5 because 2 and 5 multiplied together will give us positive 10. But in this case, we have a negative. So we know something like that wouldn't work. We also can't have two negative numbers because negative 2 times negative 5 is still positive 10. So that won't work. So in that case, what we know about our products is that one number has to be positive and one number has to be negative to give us a negative 10. So knowing that, let's just find some factors of 10 first. So starting off with factors of 10, we have 1 and 10, and we have 2 and 5. So let's say we try use 2 and 5. So using, let's say using minus 5 to start with in positive 2, minus 5 times 2 gives us negative 10, which satisfies this side. But now what we want to work on is we want to make sure that the plus 3x here is also satisfied. So then that's when we use the diagonals again. We follow the path of the diagonals. So x times 2 gives us 2x. Then we add it with minus 5 times x, which is just minus 5x. So we know that's 2x minus 5x, which gives us minus 3x. And we can see that that's not quite just right, because this is a plus and this is a minus. So essentially, some of this might be guess and check at the start, but with more practice, it'll kind of become more like second nature to you. So we know that minus 5 and 2 doesn't work just right? So what we can do is we can actually flip the signs. So instead of minus 5, we can write it as positive 5. And instead of 2, we can write it as minus 2, right? So minus 5 times minus 2 gives us minus 10, which works on the right side. Now in the middle, we want to see if this works. So we want to follow the products again. Minus 2 times x is minus 2x. Plus 5 times x, which is 5x, which when you sum them together, it's just equal to 3x. So now we can see this solution works, right? And as mentioned earlier, when we're writing the factorized version now, what we want to do is we want to follow it straight across, and just like that. So we can see that our final solution now is going to be given by x plus 5 in brackets, x minus 2 in brackets. And that is how we factorize a question like this. Now what we can also go on to is I can give one more example. So let's say in this case, we are given x squared plus x minus 12, and we want to factorize this. Now, listing out the products again, we know we have 1 and 12, we have 3 and 4, we also have 2 and 6, right? And thinking about it, well, at least the first thing you want to be thinking about is you want to look at the end with the constant term. So we have a minus 12, right? And when we see a minus, we know that the two products always have to alternate. So let me just get that ready. Now we know the two numbers here have to multiply together to give us minus 12. And the only way for that to happen is if we have one positive number and one negative. So we know it's definitely alternating. Now, going on, we can test different numbers and we can try to see what works. We can plug in, let's say, 6 and minus 2 as an example. So 6 times minus 2 gives us minus 12, which works. But when we go across the diagonal, we have minus 2x plus 6x, which gives us 4x. Now 4x is way too big for this x. So we know we have to get some numbers that are closer together. So in that case, what we can do is we can rule this out as an option. We know that it's too big, it won't work. If we tried 1 and 12 in any case, let's say we can just do minus 12, positive 1. What happens is x times minus 12 gives us minus 12, plus x times 1 gives us x. So minus 12x plus x gives us minus 11x, which is still too small or too big. So we know this option won't work. So in that case, we know it's going to center around 3 and 4. So let's say we tested minus 4 and 3 to begin with. If we do minus 4 times x, we get minus 4x, plus 3 times x, which is 3x. We can see that we get minus x, which is opposite in sign of what we're looking for. So in that case, finally, what we can do is we can just flip everything around. So instead of minus 4 and 3, what we can have is we can have positive 4 and minus 3. So we can see we actually switch the signs around, but we keep the numbers the same, right? And finally, trying that one, minus 3 times x gives us minus 3x. X times 4 gives us plus 4x, which gives us x. So we can see everything is satisfied. So x times x gives us x squared. Doing the cross method following the diagonals and adding them up, we get x, and 4 times minus 3 gives us minus 12, which works out just fine. So once again, writing across, that would just be x plus 4 in brackets, and writing across from here to here, this would just be x minus 3. Perfect. And to test, if you want to make sure that you're correct, we can expand to make sure that our expansion is correct. So x, oh, that might not be a clear color. So x times x gives us x squared. X times minus 3 gives us minus 3x. 4 times x gives us 4x, so we can flip them around, it's the same thing. And 4 times minus 3 gives us minus 12. So what we're left with is we're left with x squared plus x minus 12, which is just what we started with. So I hope you learned something in today's lesson. This is just factorizing quadratics that are monic, and what we used was we used a cross method. So next time what we can go through is we will go through how to do non-monic questions, and if you have spare time, you can practice this example for many other types of questions. All right, thank you, and take care.